All right, so we'll begin. This is the history and use of R, and I'm Joe Cambarakis. So first, just some ground rules. The first thing, interrupt me. If you have a question, raise your hand. It's going to be much better as a dialogue. It's going to be a lot less work for me if you do some of the talking. So anytime you have a question, raise your hand, interrupt me. Chances are if you're thinking something, someone else is thinking that as well. Okay. This is my opinions. This is what my slides. This has nothing to do with EMC where I work or with the meetup. So if I say something inappropriate, which I hope I don't do, it's on me. And finally, I'll make the slides available online later. I'll put a comment and put it up on Amazon Web Services. So you don't have to see a really amazing slide and take a picture of it. So they'll all be available later. Okay, so one thing I want to emphasize is we're not going to have a lot of code or really any code. So I could kill you all with lots of code like this, but does anyone actually want that? I don't think so. It's very hard to follow. You need to get laptops out. So very little code. There'll be almost code, but nothing to follow along. I'm not going to open up R or show any examples like that. The other thing is, I'm not trying to sell anything. There's no product here. There's no sales pitch. I'm not going to try and get emails and sell you anything later. I am going to try and sell you on R and the benefits of using R, but there's no product. There's not a sales item or anything like that. I won't make any money from this presentation or anything that results from it. So I'm Joe Cambarakis, and more importantly than my email is my Twitter handle. So this is the best way to get a hold of me and to reach me. And I often find that these things are much more important as we move into the future. This is almost more of your identity than an email or something like that. So what do? I work for EMC, and I teach a data science course for them. I teach data science and big data analytics. And this is a rather esoteric job. There's really only a few people that have a job similar to this. And what I do is teach a course, and I teach it all around the world. I've taught in Saudi Arabia, as you can see here. I've taught in Japan. I've taught in Australia, Singapore, Ireland, England, the US, India, Australia, lots of different places. So I teach R all around the world, and I've been teaching for over a decade. And I've even been featured on Japanese television for teaching in R and analytics. They interviewed me for hours on end. And I was on TV for 5 minutes, so it was very interesting. So it all began, I went to WPI, so I'm a Massachusetts native, and I actually live here in Somerville, so it's only about a 2-mile walk here. So I went to WPI, and I have a degree in electrical and computer engineering that I don't really use. And you'll find this is a very common theme with analytics, with data science, is people have degrees that are a little bit off from what they do. It's still a STEM degree, but it's not necessarily analytics. I took Stats 1, Stats 2. Analytics really began when I went to Bentley University for my MBA. So while I was there, I needed a concentration for my MBA, and they had a really, really strong analytics department. So that's where I ended up. And the real reason for this is it's a little bit odd, and I'll take you through that journey. But Bentley is actually a very, very well-rated and prestigious big data school. They have big data sets to work at. They focus a lot on tools. They focus a lot on analytics. So there's actually a source here, and it goes into what schools have very good programs related to this, because it's such a new topic. The parallel, if you think years ago, computer science in the 60s. Did any university have a computer science program back then? Probably maybe one or two, but most didn't. It ended up being parts of somewhere else. And Bentley was very much like this. They didn't have a data science department. It was part of stats. It was part of marketing. It was part of IT. And that's just how computer science used to be. It used to be part of math, part of physics, part of statistics in different places. So while I was there, I had 2 professors that really guided me through analytics and introduced me to R. So the first one was Dominique Houghton on the right, and she really focused on learning tools. She taught everyone SAS, taught everyone SPSS, made sure people knew R and had certificates. And then Sam Wolford's really the person who showed me how to use R. And that was in one course I took with him called Time Series. We use this text. So I had to learn time series and R at the same time, which is not something I would recommend, because they're really 2 separate things. but really drinking from the fire hose, learning R and time series at the same time. And this was the text I used. I still have my copy. So the first questions I really had were, what is R? It's a letter to me. Google didn't really help too much, but R is two things. So it's free, but it's software for doing stats and graphing. Those are really the two things that it focuses on that's really good at. There's some other things. It's a runtime environment. It has debuggers, has graphing tools, ability to run scripts. But really, you should think of it as stats and graphing. And the two are very related, because if you're going to do stats, you want to look at graphs of the outputs. And most importantly, what's the hashtag for R? You can't just type R in Google and expect something. So the hashtag is rstats. So here you can see lots of people using the hashtag. There's different kinds of R Twitter feeds and so on. So I was focused on these kinds of things. What is the hashtag? How do people use it? All right. So R really began in the early 90s, and it was developed by these two people. They were professors in New Zealand, Robert Gentleman and Rossi Kata. And they created it, and really it was an adaptation of S, which we'll see in a couple slides. So it's like a dialect of S is the way to think about it. And they said, you know, there's statistical things we want to do. We don't want to just write C or C++ code. So they're really the focus and the developers. But it's a dialect of S. S is a language that was developed by Bell Labs. So the first version of S in '76 was developed by John Chambers. And it was really just a bunch of Fortran packages, sort of stuck together. It wasn't really its own language. Later in '88, it was mostly rewritten into C. And this was a big fundamental change in how it was done. Because at Bell Labs, they said, we want to do statistics, but we don't want to sort of combine it with coding. If you think about statisticians in the '70s and '80s, did many of them code? Not really. So they needed a sort of workaround. You don't want statisticians writing Fortran code back then. And does anyone know what writing Fortran code was like back then? Wasn't pleasant. Oh, a couple people have. All right. And then really what R ends up looking like is with the 1991 release. And these are sort of the books, sort of the white papers that came about with them that they released. And this is really what R ends up looking like. So it's a sort of dialect adaptation out of S. There's some changes from S, though. One of the most important ones is the lexical scoping comes from Scheme, a different language. And this was a really big improvement. S was not quite as functional, and there's a lot of details into this scoping, and we'll look at it very briefly. So when you want to find a variable in R, you have to know where to look for it and where it'll exist. So if you have a variable, just A. Where does the program look for it? In R, it'll look first in your global environment. Environment is just a set of states where your data and functions will exist. And the global is your workspace, whatever's in memory. So if you made an A, that's where it's going to look first. If it doesn't find your variable A, it's going to look into your packages. And we'll look more at packages in a few slides. So it's where to look for things. Is it exist? Does it not exist? If you don't find A here, and you don't find A here, it'll throw you an error. These kinds of things. So where to look for all our functions. Where to look for our variables. Because you don't want to have to just use numbers all the time. You really want to have variables. And a lot of R comes from Fortran. So we had a couple people who remembered Fortran. Who's written Fortran here? Wow, more than I expected. Who's written it on punch cards and tape? It's also a good question. A little fewer. Okay. So Fortran, on tape and punch cards, not the greatest language, but then nothing's a great language on those kind of formats. But if you're actually just writing a script, it's very, very good. And why has a lot of R come from this? Well, a lot of things haven't changed in statistics. If you have to compute an average, it was the same algorithm it was 40 years ago. So just keep using the same Fortran algorithm. It was certainly fast, and there was no issues with it. So a lot of the underlying statistics haven't changed. If you need to compute a standard deviation, that's already written. You don't want to start rewriting a standard deviation function in C++ or in Java. So a lot of the Fortran was written correctly, and they continue to use it. So under the hood, if you look at the source code for a lot of the files in R, some of it is in R code, some of it's in C, and then some of it's in Fortran. But if you actually look more at line by line, there's not quite as much R, and there ends up being a lot more Fortran, a lot more C. So these are really the fundamental languages under it, which is how it sort of becomes a dialect. And there's a lot of argument. Is R a real language? Is it not a real language? Well, it does have its own parts, but it's also part of other languages that are built up. Okay, we talked about being free and open source. So it was open source in '95, and that's when they really adopted the new license. And there's a few parts to this. So the freedom zero, so to speak, is to run the program for any purpose. You could run it at work, you could run it in an academic setting. All of these are fair use. And then you can study how it works. So you can look at the code. And then you can redistribute copies, and you can give it to other people. And most importantly, you can improve it and release your improvements. So this is really fundamental to why R is popular and why we're all here, because it's free, because it's open source. So this license and R is mostly managed by the R project. So this is a foundation that's nonprofit, and they set what the releases are, they set some of the guidance, they provide compilations of different things, such as books and websites, and they set standards for documentation. If you want to make a package, which we'll see shortly, what needs to be in it, what the naming conventions are. So it sort of keeps things organized. There's many, many contributors. Some of them are listed here, but there's also many more, and you can look on the website to see them. If you wanted to hire someone, some of these people would be really good candidates for our programmers, but there's many, many, many contributors. We'll see really countless contributors. So some of the design of R. So it's an object-oriented language. So we have objects, and these are going to have data or state, and then behavior or methods, and we'll create other kinds of objects. You can make function objects, you can make data objects. If we wanted to make that variable A, well, we'll have an A object. So it's object-oriented in this sense. Is that clear? Anyone iffy on that idea? All right, good crowd. No, pretty comfortable with object-oriented. All right. All of R is functional. So if we have a function, and a function will always have parentheses like this, then that's how we'll manipulate things. So here we have mean, which computes an average. And we'll have something like plot. So simple functions, clean naming conventions. And it's important to note that it is case sensitive. So here mean is all lowercase. If you had capital M mean, it'll throw you an error. It'll look with the scoping rules for a mean function that begins with M. So always be careful of cases in R. And it's an interpreted language. Anyone familiar with this photo? So I needed a picture for interpreted. And there's not really good pictures for interpreted language. I said, all right, well, I'm going with an interpreter here. So this is from the Mandela funeral, where someone just pretended to be a sign language interpreter for the crowd. So R is interpreted. It doesn't get compiled and then run all at once. It'll run line by line. If you type in, let's say, 2 plus 5, it'll interpret that code and then give you an output. So this is what's meant by an interpreted language. Okay, installing it. So there's many, many hosts, and there's many hosts mirrored all around the world. The simplest way is to go to the Comprehensive R Archive Network, or CRAN for short, and download it. The Windows version is 54 megabytes. The nice thing is it'll find out what kind of operating system you're on and then make a suggestion. You don't have to actually find your operating system. So this is a pretty small install, right? What was the last time you installed something that size? Probably not recently. Most programs are much heavier, much bigger downloads. Sometimes you get them on USBs, sometimes you get them on DVDs, but this is a very, very small install. And it's pretty lightweight. And that's one of the big advantages to R. So one place that it's hosted is by RStudio at this URL, but there's many other hosts in different countries. This just happens to be the closest one to us here. And There's versions for Linux, for Mac, for Windows, and there's different flavors for Linux as well that you can download. So there's many, many options for downloading R. But one of the nice things about being interpreted is it doesn't care too much about the operating system. So a lot of the ways you're going to interact with it are through a command line. So you have this, you open it up, and you get a prompt. And this is where you could type 3 plus 5, and it'll give you some output. So most of it is traditionally command line. And just enter code and hit enter. You can also run scripts and open scripts. That's a little bit trickier to do. Now, one thing that's really important in R is this idea of packages. When you get that 54 megabyte install, it really comes with 3 packages. The base package, which has things like mean in it. The utils package, which has ways to read files. So if you wanted to read a CSV file, you do something like that. So it gives you access to file reading. And then a stats package. Because what's our main goal with R? For stats. So if you want to make a linear model, if you want to do compute a standard deviation, these are in that package. So there's packages for many, many different things. And there's many different packages available at different places. Most of them are hosted on CRAN. And these are packages that meet certain standards, that have certain goals, that have certain functions in them. But they're hosted other places. You can have your own package and host it on GitHub. And we'll see an example later. RStudio hosts some package, Bioconductor, Revolution R. Anyone can make a package and release it. That's one of the great benefits to it being open source. Again, the number of packages, and this got, I think, washed out. It looks much better on my screen, but I'll walk you through it. So this is dates here, and it goes from about 2002 to 2015. And this is number of packages. So we're right now at 5,000 packages. And this is a huge increase. When I started using R, right around here, there was about 3,000 packages. So in the past 4 years, they've made 2,000 new packages. And these do all kinds of things, reading different kinds of files, doing different kinds of statistics, doing different kinds of graphics. So if you think about it, that's like 6 packages or a few new packages every single day. There's lots and lots of work and things going on with R. So always new packages, and they do things you would never imagine. So here's a list of some of the most popular packages. So primarily Plier. So this is a package that lets you manipulate data. Because what you end up doing with statistics is sort of manipulating data, changing the format, adjusting it. And that's what Plier does. It has different functions that let you adjust data. Digest is a package that lets you create hashes. So this is not hash as in like a Twitter hashtag, but it's sort of a recoding of data. Plot2, which is the second implementation of ggplot. And G stands for Grammar of Graphics. Very, very popular package. And we have some download numbers. This is probably much, much, much higher because they're mirrored all around the world. Color space, which is actually similar to our color brewer, which gives you different palettes. Gives you, instead of just a standard colors. You can have color 1, 2, 3, 4, and it's like red, green, black, yellow. But you can also create different kinds of shading and different kinds of color with these packages. If you're working with strings, there's a package called Stringer that lets you manipulate strings. Gives you uppercasing, lowercasing, deals with spaces, hashes. Reshape 2, which is a reboot of Reshape, which is very similar to Plier. It lets you sort of adjust data. My favorite named one is Zoo. So when I was in school, I saw Zoo, and I went, are we really naming things Zoo? What's the idea behind this? But it actually stands for something, thankfully. It's not just Zoo. So Zoo is Z's ordered observations. So this is very useful for things like time series, which are going to be ordered. If you have to do financial analysis, you want ordered time series. And Proto, which is very vague. Prototype object-based programming. What does that accomplish? Well, it ends up being a dependency of ggplot. So there's packages that reference other packages. They have dependencies. So if you want to use ggplot2, there's a couple other things you'll also need to use. There's a function in one of these functions that references a function here. And then scales for doing graphics. So we really see the two most common types of packages are for manipulating data and for doing graphics. And these are really, really useful things that you end up having to do. Statistics is important, but if your data can't be manipulated, you can't really do any statistics on it. So you see this trend of manipulating data and then plotting the data. So who maintains these packages? We have 5,000 packages. Who's maintaining them? Who's in charge of them? So this is a graphic that shows some of the people who do so and how many packages they maintain. And number one is Hadley Wickham with over 30 packages. So he actually developed a lot of these Plier and ggplot. And he's the closest thing to an R superstar that there is. I saw him speak at Strata a couple years ago, and the room was full. The room had people sitting on the floor, and it was sort of like the end of the conference. So people were itching to get out, but he filled the room. He works for our studio, which is actually located nearby, and is always tweeting and very, very passionate about R. He develops lots of packages, gives talks. He was a PhD from Rice originally. But we have lots of other people in this space contributing and working on packages, and there's lots of community involvement with them as well. So one of the key cornerstones in R is the objects that the data are stored in. The most common one is called a data frame. So I have a quick example here of just MT-CARS, which stands for Motor Trend Cars. And you want to think of a data frame as a vector of vectors. And this is really, we have some observations, which are in rows or tuples. And we have some features or variables, which are in the columns. So this looks a lot like a database table. This is how most of the data that you want to work with is actually stored. So this is very similar to a database table. In R, it's called a data frame. So it's just a vector of vectors. So you can see there's different variables like miles per gallon and cylinders. And then different car types here. This is the most common type of object in R that you'll end up working with. So what are some of the capabilities in R? We saw that we can manipulate data. Yeah.
Were the column headers part of the data frame, or was that just an example of the column headers?
Yeah, so those are part of the data frame. And you could access it just with the column names. But you can't really do any manipulation on them. They're not like data per se. This is more of what you're concerned with. This is the data, this is sort of the metadata, the column names. Is question. Okay. So some of the capabilities. Primarily, we said analytics or statistics and graphing and visualization. So we can do basic math. You could do addition, subtraction, multiplication. You could also just use a regular computer or do it in your head. But it is possible to do addition, subtraction, these kinds of operations. We also get basic statistics, so computing variance or standard deviation. Looking at probability distributions if you need to do kind of t-tests, z-tests. Lots of machine learning. So someone mentioned that they're hiring a machine learning person. Hopefully they use R. And there's lots of different packages that have machine learning algorithms in them. Optimization and mathematical programming. So you can still code. You're not limited to just what's there. It's open source. If you want to make a function, if you want to make a package, you can do that. So any kind of mathematical programming that you want to do, any kind of optimization. There's packages built around doing these things. You need to do signal processing. So again, things like Fourier transforms. They haven't changed over time. The ones that were written 40 years ago are just as effective at transforming signals. If you need to do simulations, so there's Monte Carlo packages. If you need to generate random numbers, there's lots of different ways to generate random numbers. You could generate uniform numbers, binomially distributed numbers. You can also do lots of statistical modeling. If you need to do a linear regression or a logistic regression, lots of modeling functions available as well. And statistical tests, p-tests, f-tests, and so on. If you need to graph, you can do plenty of static graphs, but there's also some dynamic graphing capabilities as well. Any kind of formatting, adjusting, but primarily you're going to do modeling and plotting. So here I have that same MT-CARS example, and we're just going to make a linear model out of it. And then we're going to plot the output. This is really the key to doing statistics work. Creating a model, plotting a model. So this GUI that I'm showing is RStudio. And really, it takes R, which is just this console, and puts a development environment or a GUI on top of it. There's a couple other parts. So we have a script here. So instead of working all command line, you can work from a script. And this is much, much more useful in case you need to reuse your code or if you want to edit and save your code, instead of just working all command line and copy pasting from Notepad. Or something. You can save scripts. The scripts are read as just .r files. So that's the file format. But you can open them or edit them with something like Notepad. The other Windows panes you get here, and they're again a little washed out, you get your global environment. So if you create that variable A, that's where it'll show up, in your global environment. If you make a function, it'll show up here. We also have your history of commands, your local files. If you do any plotting, you can look at what packages you have available. So some of them you have to install and load, but things like the stats package, the base package will automatically load for you. And then if you need help, there's different ways to get help documentation access in this. So RStudio is free. It's created by a company just called RStudio, and they're located just across the river. And they also host R, and they're very, very active. They make lots of packages and open source a lot of their material. Another option is Command R, and this is, again, another GUI, another free GUI. And it has a script and then your output window. So this is really like your R console, and this is your script. But it also gives you some drop-down menus. So if you want to do some statistical modeling, you have this drop-down option. So instead of having to memorize the function and how to call it and all the arguments, you can do it with this. And this is a lot more similar to SPSS. Anyone here used SPSS in the past? Yeah. So more of a drop-down type feature, similar to that. The GUI I actually learned R on is called TinR. And it's mostly just a script up top and the output here. But again, another free GUI. And there's many, many GUIs that are available. Just find one you're comfortable with that you want to work with. RStudio is the most commonly used GUI. And I think it has a lot of intuitive features built in. But again, there's no right or wrong for a GUI. If you want to work just command line, you can certainly do that. OK, so how does R compare to other types of softwares? So we don't have R anywhere here, and this is a Gartner Magic Quadrant. So I did go to business school. I still have that mentality. I like to see these sort of squares. And we don't have R. Because it's open source, there's really no company behind it. Here we have companies like Microsoft, Alpine, Oracle. So in this space, SAS is really a leader. And then IBM's listed here because they bought SPSS. So that really helped push them up. We have another sort of open source tool in KNIME. But Revolution Analytics is trying to monetize or commercialize R. And they've moved up a great deal and are really one of the top few players in this space. So there's not a particular R company that's making money. It's hosted by an organization. It's open source. But we can see sort of a flavor of R. Yep. The access labels are ability to execute here, and then completeness of vision here. Go to lots of presentations or read Gartner reports. There's one of these on every single kind of topic. If it's data storage, cloud, lots of different topics, they release these. Okay. Now, another way to think about it is looking at Google Scholar hits. This is a much greater representation of how it's used academically, how popular it is academically. And we see in the early 2000s, everything was sort of clustered here, but R has really taken off and is the most commonly cited and used tool in scholarly or academic research. We also see Stata, which is more of an econometric package and tool. But one thing that people did is they rewrote I believe, 150 of the most common Stata functions into R. So there's really no reason to use like a commercial tool when R has all of those functions built in, plus all of the other functions R already had. But we see some other things like Minitab and statistics. OK. So here's another comparison that some of my classmates actually did a few years ago, comparing R, SAS, SPSS, and MATLAB. The first line, I think, is the most important line, and it's cost. So R is free. SAS is very, very, very expensive, very, very high seat cost. It'll vary based on which version, but we're talking thousands and thousands of dollars for a license. SPSS is also very, very expensive for a license. and that's through IBM. MATLAB also has a fairly high licensing cost. But you do get some benefits from these costs if you need things like documentation or validation. So R doesn't have a company doing trainings behind it. It doesn't have a certificate like SAS does. If you want to, you can study SAS. SAS administers a test, and you can get a certificate. They have different levels of these certificates. R doesn't have this. Because it's open source, there's no company trying to monetize it. SPSS has certification. MATLAB does also. Some of the modeling capabilities. R has many, many, many more functions possible. If you have thousands of people in the open source community working and creating functions, you're going to just get more of them than the more commercial tools. So if you want to build time series models, SAS doesn't have all of them. Garch and Arch models aren't in SPSS. MATLAB is missing some models. But R has dozens and dozens of just time series models if you need to build a Holtz-Winter or Riemann or Garch. And it also has many, many other functions for doing everything you can imagine and then some. It would be impossible to learn all 5,000 packages and every function within them. Okay. Now, there are some companies trying to monetize it. They're trying to make up for these lacks. So the lack of training, the lack of customer support. And one of them is RStudio. So they have a commercial desktop license available and also server license that will give you these things, give you documentation, that will give you customer support and ways to interact with R. Also, Revolution Analytics, Revolution R, is another version, another way to get sort of R in a more enterprise-ready format that has customer support, that has training, and these kinds of things. Again, they also have some improvements. They sort of make their own flavor of R, is the way to think about it. Much like Red Hat is monetizing and supporting Linux. This is similar to what Revolution Analytics does. Okay, so where is R now? Right now, it's on version 3.11. And this was just released earlier this month. And there's pretty frequent updates. The last big update was when they went to version 3 last year. And this really changed a lot of the possibilities, how much data it could handle, and some of the underlying code. But they'll generally do small version updates periodically. There's user conferences. So the most recent one was at UCLA. It was very, very popular, well attended. But a better way to think about it is with our user groups worldwide. So this is from a year ago, but there's hundreds of our user groups. There's one here in Boston that you can join, and it's actually administered by some of the people that work at RStudio. And they've held meetups in different locations. So where it's going, where is R? They did a survey of some engineers, and they said what language is the most useful, most common, and naturally Java came out on top. And people use Java on the web, on mobile devices, on desktop. And so that was the baseline. That was 100%. If you had to learn one language and one language only to get Java's the way to go. And then they found that things like C, C++, Python, C# are also very common in different applications, very prominently used. PHP, JavaScript, Ruby, and then R actually came in 9th. And it's very impressive when you think about, well, how slow it is compared to all of these, how it's really just for stats and graphing. Java can do much, much more than just stats and graphing. So here it's well above SAS. It's above MATLAB, which is, again, very similar. So it's a very big change in how people are doing things. And the big change behind that is it's free. It's open source. There's lots of functions. There's lots of availability. So that's what's driving this huge growth that we saw over time.
What's your fourth icon there? It's like a...
Oh, so the fourth icon is in a microchip. So if you had to get something on a PIC or microchip, you don't want to have to do R because it's interpreted and it's slow. But if you needed to, let's say, put a chip into a coffee machine, then you'd do it in like, okay. So where else is it going? There's lots of different extensions and ways to interact with R. So there's this really great package, RCPP, that will turn your R code into C++ code or vice versa. Let's go from C++ to R. So this will get you sort of the benefits of both. You can build a statistical model in R, and then implement it, productionalize it in C++, which will be much faster. RLVM, which is very similar to go from R code to native code. And then H2O is a package that lets you manipulate big data. So there's lots and lots of things in development, and it's going towards the future, having different language availabilities. Yes?
You see what I remember reading was the address space was only 32 bits?
Oh, no, R can handle 64-bit. You can get a 32-bit version, but it can handle 64. Yeah.
That's limited by the operating system.
Yeah.
For example, if you're on Windows, if you're on the wrong Windows system, even if it's 64-bit, you don't handle the 64 bits.
I understood that R deals with data only in RAM, in memory. Does H2O get around that?
Yeah, so the question was R's limitation being in memory, and that's good. I do have a slide about that. But H2O helps you get around that memory problem.
I think in memory is virtual memory. So if you've got a 64-bit, that's 1 terabyte address data space. But it's not limited to the memory on the box.
So some of the good and bad things about R. So I have this quote from Vocalgo, who was at Google, and he said, the best thing about R was that it was developed by statisticians. And the worst thing about R was that it was developed by statisticians. So if you think about the drive behind it, it's really meant for statisticians to do statistical modeling and plotting. That's the drive for it. That's really what it's good at. It's not good at doing things computer programmers want to do that are separate from those. So if you're a statistician, it should all be very intuitive. It should all make sense. It'll do what you want. You can do things without creating loops. You can do recoding without looping. But again, it can be a bit cumbersome if you come from more of a computer science background. Even little semantics like how you use a period will be very unintuitive to a computer scientist. So one great thing about R, one good, is that it's open source. There's many, many contributors. It's free. And there's this great community. And we ourselves are part of this great community here. One bad thing is it's open source. So there's not customer support. If there's a feature that doesn't exist, well, it's up to you to write it. It's up to you to try and find it somewhere. But if it's not there, you can't just tell your salesperson, I need this in the next version. So there's frequent updates. There's always new packages. There's new packages almost every single day. They're always improving the code. They're always doing bug fixes. You don't have to worry about the company going bankrupt and then not having any customer support later. But again, one bad thing is there's frequent updates. So you're going to have to install and update packages pretty frequently. One thing I was preparing for this presentation is I was going to look at this R chart package. I said, oh, that's a good one to reference. So I tried to install it, and I got this wonderful, oh, it's not available. So it expired. So one bad thing is these updates. If the people who maintain the packages, if the contributors don't maintain it, then you're doomed. So anything you did, you can no longer do unless you get like an older version of R and the older version of R charts. And then you're going to deal with a big headache trying to keep control of different versions. Another bad thing is the documentation sometimes. So this is a function, RJSON from the RJSON package. And this is all the documentation, all of 3 sentences. So JSON, which tells us what a JSON object is a lightweight data interchange. So going from JSON objects into R objects. But this is not very good documentation. It doesn't tell you when this was written or what the function does, what the arguments are, what the defaults are. Terrible documentation here.
On the prior slide, when is that simply that the person who maintains it didn't update the header that showed that it's available, or does that mean that there were actually functional changes in languages and it's not compatible unless someone develops it?
The latter. So there's changes and it's not available. It could be the particular mirror, but more often than not, it just expired or some system change occurred and then it no longer works and you get errors. Okay. So sometimes we get really bad documentation. There is some good documentation written with nice, clean examples, but in this case, really bad documentation. Another issue is speed. So this was all written decades ago, and it uses decades-old technology. So the code was built for processors from the 70s. So it's very, very slow, and speed becomes a big issue. It's interpreted, so this is going to slow things down. It's not a compiled language. It's not writing in assembly or Fortran that will give you fast results. It'll be fast enough working on a desktop for small data, but it will be slower than almost anything else you do. And it's single-threaded. So does anyone here actually have like a single-core processor on a machine? 1, 2? Okay, so you won't have any issues with this. But on a multi-core machine, it won't use all of them. It's single-threaded. There's ways around this. So some of the commercial flavors of R from Revolution R will give you multi-core processing. But for the most part, it's single-threaded and subsequently very, very slow. So a bad thing that we mentioned earlier is it really just uses memory. That global environment it creates is just memory. So we're really limited to this. You don't have access to all of your disk to do functions. And you'll run out of memory in R. It's very common if you make a big matrix or if you have a lot of data. If you have more than about 2 to 3 million rows of data, it just won't fit in memory and it'll crash or not run. So this is another concern, where some of the other commercial tools won't have a problem like this. Okay, so I have some examples of graphics that are created in R, which I feel much better than just code in R. So this will be a little bit more interesting. One of my passions is soccer. So this was from 1110 Gen 11's Twitter stream. And he mostly writes about the Eredivisie, the Dutch soccer league. And this is a World Cup example where he created all of these plots in R. So it looks at the Colombia versus Greece World Cup game, how many goals there were, the expected goals, and creates a graphic. So it can do statistics, computing things like expected values, and then creating graphics. This example is actually from a friend of mine from high school who I never thought would get into R. He's a political scientist, but thankfully he writes code, which we don't have enough of in the world. And he's a professor at NYU, and he made this graphic. On the x-axis, we have the approval rating of a congressman within their district, and then here we have the overall congressional approval rating in that district. So if we take a point, for example, this one here. The particular district has an 80% approval rating for their congressman, but for Congress overall, they have a 20% rating. And this is color-coded based on party, so red is Republican and blue is Democrat. And we see it's pretty variable, but if someone felt the same way about Congress that they did their congressperson, they would be on the diagonal. If you felt 50% on both. But if you look, where the diagonal would be is right here, and it's a little washed out. Every single district is below the diagonal. So every single district in the United States feels better about their particular congressperson than they do Congress in general. And you see the average approval rating is maybe somewhere in the 20s. So very, very low overall approval rating. But every single one is below that diagonal. Another example of an R graphic. Here's another fun one. This is Breaking Bad viewership. So it's millions of viewers on the y-axis and the episode index. So it doesn't all have to be really drudgery and work, but we see that big increase over time in viewership. Another example I found today was about coffee consumption on the x-axis and then GDP per hours worked. And they were trying to correlate coffee with productivity. And I'm a firm believer in this. But they fit a regression line to it and created this graphic. Not a large graphic to create. And it was a pretty simple data set. It was GDP data with coffee consumption data. So this is a very, very common and good example for R. You'll pull two data sets together and create a graphic. And we see that the US is a pretty big outlier. Finland's an outlier. But for the most part, countries that consume more coffee are also a little bit more productive GDP-wise. But don't get any crazy ideas. There's a lot of correlation between wealth and drinking coffee. If you have no money, your GDP is here, you're also not going to drink any coffee. But if you have lots of money, you can buy more coffee. Okay, Another example I really liked. So this was a package hosted on GitHub, and it is a color package. And it lets you get color palettes from Wes Anderson films. Is anyone familiar with Wes Anderson films? These are movies like Rushmore, Grand Budapest Hotel, Life Aquatic, Fantastic Mr. Fox if you have children. And it just gives you colors that relate to these movies. And I can't imagine a use for this, but I was really interested in the fact that I could make colors for movies. And I don't know what kind of analysis you would do, but there's all these color palettes that relate to movies. So if you needed the Rushmore color palette, this is something available, free, open source, and you really see that community-driven. Okay. So where to go from here? I told you I would sell you on R and want to be more interested in it and learn how to use it. So one place to learn is Coursera. This is a really good option because it's free. And they have many, many courses that use R. So this is a MOOC, massive online open course. And there's many courses. So one simple one is computing for data analysis. They have another one called R programming. And they have an entire track based out of Johns Hopkins that teaches R and then how to use R statistically. They're usually 4-week courses, and they have examples of code, and you submit your code. And they tell you even basic things, how to install R, how to install a GUI. So this is a really good free online resource for doing it. I've taken many Coursera courses, and one nice thing is that if you complete the course and get a certificate, you can then link it to your profile on LinkedIn. So that's one benefit. Another way to learn R is through the course I teach at EMC. So we have a day that focuses on introducing R, exploring data sets, creating graphics, and then we use R to do analytics, to do clustering, regression, naive Bayes, and different kinds of things. So this, I've taught, I guess, thousands of people now how to use R in this. And I don't get a sales commission if people sign up, so don't worry about me getting anything out of this. But a very good resource for learning R in a corporate setting. Our studio also has courses. They teach online courses, they'll teach in person, and they also create books. So very, very good resource, and they have very good teachers that create lots of R code that work with the community. So another way to learn R. Now, the best way, I think, is Data Camp. Is anyone familiar with Code Academy? It's a website? Okay. So this is actually very similar to Code Academy in that it gives you little examples to do and immediate feedback. So it'll have some instruction here, some code here that you can type in, and then it'll tell you whether you got it correct or incorrect, and then move on to the next one. Very, very good resource. I've used it a lot. And if you had to learn R, this is the best way to code, I think. Doing small examples that build upon each other with real-time feedback. This is going to be way better than me presenting on an overhead. I can't compete with a laptop, and I certainly can't scale. It's on the web. It can scale to millions of people. I can only scale to about 100 people here, and certainly not with code and laptops. So a very, very good resource, Data Camp. And they have different tracks, and I think it's a really fantastic website. So if I had, this is where I would start with someone new if they had to learn R. There's also some very good book series. So the way I learned R was from the Springer series. And these do a very good job of combining R and statistical methods. It's a series just called Use R, and they have things like Bayesian networks, bioconductor data, beginner's guide, R for Stata users. Lots and lots of different books that are very good, relatively inexpensive as well. And they have lots of R code. Sometimes there's even a package associated with the book. So you download the package, and it has the data sets the book uses as well.
I can't see the publisher.
Oh, it's Springer is the publisher. And again, I'll make the slides available. I'll put them on Amazon Web Services, and then put the link on the meetup group for after this. Another great book, and one that I learned from, is Art of R Programming. So lots of good examples, more like a cookbook than anything particular with heavy stats like the Springer series. Okay, another great way to learn is from a boot camp, and the Boston Analytics meetup group holds these boot camps many times a year. They're usually at the Microsoft Research Center, which is in that direction, and they're very, very inexpensive. They're usually about $5 to $7. And there's lots of people that come in and learn R. There's code, there's data sets. There's instructors. And if you look very, very closely, this is me volunteering. And this is organized and run by John Beresek, who's here. So if you have questions about this, you can ask him. But the meetup group is very, very good and has lots of examples and old examples from there. Another great resource is these online videos that are 2-minute R modules. So it's just 2 minutes how to do something in R. And my favorite one is they use R to make a timer to then make coffee. And it just says, all right, we need to pour it for so long, we need a timer, we'll build a timer in R. But a lot of the examples, I believe there's about 200 videos, go into how to make a plot, how to change the title of a plot, how to manipulate data, and these kinds of things. So there's lots of free, very useful resources on the web. A very good blog is r-bloggers, and this will post updates about R. It'll post different research, it'll post other articles. There's lots of different parts. If you want a job doing R, if you want to read, in this case, variable selection. And they update usually about 5 articles a day on r-bloggers. And one feature I really like is that it'll show you which one of your Facebook friends also likes it. Another great web resource is Stack Overflow. If you have a question in R, generally someone else has had that question before, and it's almost always here. There'll be a question, there'll be some sample code, then there's usually an explanation in the sample code. So if you're trying to do something, this is a great place to look. If you have a new problem that hasn't existed, you can post your own question and people will give you an answer. So very, very good web resource in Stack Overflow. And this isn't just for R, it's for other languages as well. QuickR is another website that incorporates a lot of basic statistics into teaching R and has lots of graphics and tutorials about how to use R in more of a web format. Again, a user group is very, very helpful. So we see that there's user groups all around the world. There's one here in Boston that has a meetup. And there's lots of conferences available also. So a good place, they'll run instruction or you can network at these also. So wrapping up, my closing thought is, remember that R is a tool and it's a statistics tool and a graphical tool. So make sure you use it appropriately. You can do other things with it, but again, if you have a wrench and you use it appropriately to loosen and tighten bolts, that's good. If you start hammering with it, if you start using it as a lever, you're going to run into problems. So just as with R, think about it as a tool for doing your statistics work, for doing your graphical work. Okay, so thank you to HackerDuce and to Vishal for organizing this, and thank you to the sponsor. I just found out about the sponsor today, so I don't have a slide to thank them. Okay, any questions? Can we wrap up?
I've heard that you show the growth curve of packages and how it's nearly doubled in the last couple of years.
Yes.
And I've heard from some heavy R users that actually the package that CRAN and the submission of packages to CRAN has gotten so large, and you said that it's averages out to about 6 a day. Well, the people that haven't submitted yet, they're about to submit, aren't talking to the other people that are about to submit. So you get 6 new packages a day, 3 could be the same thing. So if you're going from 3,000 to 5,000, 1,500 of those could be on the same topic. So how does that get settled? How does that get organized? How do you find from 3,000 to 5,000?
That's one of the trickier things. Because it's open source, there's so many people working together, you don't have a manager saying, all right, these are the features we're going to build. And it's just sort of a growing pain or a problem with R. Generally, there's going to be some replication, but people do try and communicate through Twitter especially and say, this is my GitHub, this is where my package is, I'm trying to do this. People can then make comments and adjust and like edit the other people's code.
Taskview is a nice place to see groups of packages together.
Taskview? Okay. That's what I'm going to look at. So Taskviews?
Yeah, Taskviews. It's just maybe.
Yes, that's a good resource. I'll add that to my slide.
Short description that kind of relates all the packages.
Yeah.
Sort of like there's a one for time series for machine learning.
Yes, that's a good resource. Add that to my slide. Okay.
You mentioned you alluded to graphs are mostly static, but there's some dynamic. And I mean, I've seen things where you can like move, but I wondered what, I mean, is there packages for doing things interactively, or I just wonder what
So what kind of graphing capabilities exist in R? So it's very, very good at static graphing. There's ways to have more dynamic graphing. There's a package called Shiny that'll do that in HTML. I would say if you want really, really, really fancy, nice graphics, you'd probably want to use another tool. So R is very good in that it can make plots, and it'll do it quickly and easily, but something like D3 I think is much more useful, much better, and also much, much more complicated. So I would say R is good for like statistical graphing and modeling. If it has to be very interactive and put on the web, then maybe D3 is a better option. D3 is data-driven documents with the Java script library.
How actively do you think R is being adopted by corporations? In general, I feel like a lot of it, right now it's being by academia. So do you see this trend also kind of going in corporations too, like a company like ABC, for instance, actively adopting it?
Okay, so the question is, how do you see R being adopted by corporations? So there's a good split. There's some corporations that, because of auditing and accounting reasons, won't use anything open source, especially big consulting firms. They have to use a tool that can be validated, audited, and there's no worry about the open source part. So it is a little bit slower at adoption in corporations. But you'll find that if you have a free option that's a lot less than some of the commercial tools, it will start to get adopted a little bit more and more. And as it's used academically, it's then going to be used more in a professional setting because people are being trained academically and then moving into a professional setting. So it's slower than academic because schools don't have thousands of dollars for seat licenses, but it's getting some adoption. And companies like Revolution R and RStudio are trying to make that push a little bit more. So I think it's certainly increased over time. Where it ends up will be pretty interesting. So EMC does use R in some places, but it also uses lots and lots of SAS, and we have a strong SAS partnership.
Just to add on to that, at EMC, they're actually embedding it in some of these storage rates, the next generation, the analytics, the array itself. So it's embedded right in the cloud.
Any other questions? Yes.
You talked about issues with speed and also memory. And you mentioned that there were commercial ways in which are there non-commercial ways?
Yes. So that's one thing that they're working on developing and how to handle this speed issue and the memory issue. So that's one thing that H2O package is trying to deal with. And there's people that have this problem, so they say, all right, can we do matrix shortcuts, for example? Matrices end up being very, very large. Manipulating them takes a lot of memory, so they'll do like portions of matrices. There's lots of tricks you can do if you like sort of get some cloud memory available. That will let you work with more data, but it is a problem. And maybe someone will, maybe in version 4 of R, they'll have a multi-core code base. But it's in the development. If someone makes it, it'll exist, which is an open source issue.
Yes. The packages you might want to look into are called FF, one of them, and Big Memory is another. They allow you to work with very, very large matrices. And there's the package called Parallel allows you to take advantage of multiple cores. It doesn't let you do everything on many cores. It's development stage, but it's something to think about.
All right. Any other questions? Okay. Thank you for coming. If you have any questions or need anything, I'll be here till everyone leaves.